Hello everybody. We are now going back to Unit 8. This will be the last unit, I think, if we can finish it before the end of the school year. And so some of the stuff will be pretty easy. You've probably seen some of it before, but near the end of the unit, we're going to combine everything that we've kind of been doing the past couple weeks with quadratics and factoring, and then put in a little bit of this stuff as well. All right, so first, we're going to talk about square roots, and specifically just for numbers that are perfect squares. In other words, the kinds of numbers that you can type in the calculator and you'll get a perfect, a nice answer, a whole number, like 7 or 10. We're not going to deal with square root of 3 or square root of 10 quite yet. Only numbers that break down perfectly, okay? And so the square root symbol, that's called a radical. And the number under the square root, that's called a radicand. Okay? Now, when you're looking at a square root problem, okay, this symbol right here basically means to find a number multiplied by itself to equal this number, okay? And that's it. And so the first level is going to be pretty straightforward. These are all going to be numbers that you can actually figure out. My suggestion would be to avoid using the calculator. Do what you can do without, okay? But we'll do a couple of these. So let's start with the first one here. The square root of 25. Well, that's what number times itself gives you 25. So we got 5, right? 5 times 5 is 25. Now, it might also be helpful, off to the side here, especially if you're going to try to not use a calculator. Think about these numbers and their squares. So think, like for example, 1, if you square it, that's going to equal 1, right? 2 squared, 2 times 2, that's 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. Let's go ahead and fill this out all the way down to like 12. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. Okay? And so when you're doing square roots, all you're doing is really trying to go backwards. So you're going in this direction. Okay? So these are the kinds of numbers, right? 1, 4, 9, 16, 25, and so on, that you can square root and you'll get whole numbers. 1, 2, 3, 4, 5, and so on. For example, 25, if I go backwards, I know that 5 squared, or 5 times 5 is 25. Okay, and that's kind of how this works. And actually, this is kind of convenient. So first example here, number 1, the square root of 144, I know that 12 times 12 is 144, so the answer here is 12. Okay, and that's essentially how these work. Okay, next one, 36. I know that 36 is the same as 6 times 6, and so that's going to be 6. Okay, and you can probably fill out the rest now on your own. A couple of these are a little bit different. Maybe let's do, I'll let you kind of figure out number 16. Let's do number 16. Oh, there's multiple 16. Okay, I'm talking about this one. So 25 over 36. It looks like a weird number, and it is. However, remember that we're square rooting, okay? And this is something that we'll talk more about later. You can kind of, since the whole thing is under a square root, you can kind of talk about looking at each one individually. So 25, well, I know that 5 times 5 is 25, and I know that 6 times 6 is 36. So the answer here is going to be 5 over 6. Okay? Now when there's negatives involved, you can kind of do things one at a time. Like for example here, I would suggest figuring this part out first, and then you multiply with the number in front. Okay, so if you ever see numbers that are together like this, if you have a number and then a radical, okay, when there's no symbol in between, we multiply. Okay, so for example, like 5 square root of, I don't know, 49. Okay. When you see 5 square root of 49 together like that, you would first do the square root of 49, which is 7, and you multiply that with the 5. Okay, so that's how you get 35. All right. All right, so that's good for this level. See you next time.